Hey class, how you guys doing today? Mr. Bean here, and this is going to be video 3, which is going to be covering mechanical equilibrium and Newton's laws, or introduction to force. Okay, so we should have this study guide here called Mechanical Equilibrium, and this is going to be, we'll say this is video 3. Okay, let me hit pause real quick here. All right. So, video 3 in our summer series, mechanical equilibrium. So, go ahead and read this first part right here, and let's go ahead and get down to section 2.1 and read about force. Okay, and we'll let you read this part here, and yeah, go ahead and read section 2.1, and then we will go ahead and touch bases here. Go ahead and read section 2.1, and then we'll continue. Okay, so uh, force is a push or a pull. Okay, so let's get a better description of that, or see what's going on. So here we have this like a little bucket here, or like a cart here, and I'm going to put a person here, and I'm going to go ahead and put a person here. Okay, so it looks like they're about the same size, and this person is going to be pulling a force to the left, this one here going to the right. So go ahead and hit go, and we see here that they seem to be exerting the same amount of force. Okay, and the sum of the forces is 0, because we have force going to the left, force going to the right, and it looks like it's 0, so it's not moving. So we'll hit pause here. Now let me throw another guy here. So we have two guys that look like they're equal in their force application, and we'll hit. Notice here. Here, let me take this back here. These arrows can also be used to represent vectors. Vectors show magnitude and direction. So see the size. Okay, let me take this out right here. So see the size of this arrow here. That tells you the magnitude, or how big the force is. So if I go over here and put this guy here, notice that the arrows are the same. So when arrows are the same size, they tell you that the forces are the same. So they give you magnitude, and this one here also gives you direction. This force is going to the left, and that's going to the right. So I go ahead and hit go, and you see here the sum of the forces is 0. So it's not moving. So there's no net force or no unbalanced force. Let me put this guy up here now. Now let's see what happens. Now notice here that this arrow is bigger now. Okay, bigger than this. So there is some leftover, or some residual force left over. And you can see here the sum of the forces also means net force. So when we let this, when we look at when we hit go, there's a net force, or sum of the forces, or a balance or unbalanced force going to the right. Let's see what happens now. See, there it goes. It's now moving to the right. Okay, like so. All right, go ahead and hit return here. Now I'm going to put a third one on here. Now this guy is a little bit bigger, so we have a bigger force here, and we can see here that this arrow is now even bigger. So there's a greater force, okay, a greater unbalanced force. Let's hit go, and we can see it's now moving a little bit faster, like so. All right, so that kind of gives us an idea behind forces, balanced forces, and unbalanced forces. All right, now let's go back to return here. And let me put this here. Now, if I go here and the forces are balanced, this is called mechanical equilibrium. Okay, mechanical equilibrium. Okay, and so if there's no net force, it's called mechanical equilibrium. Now, let me put this guy here. Okay, now we have an unbalanced force, or a net force going to the left. So all the forces are now going to the left here, or there's a movement going to the left. Okay, all right. And we'll go and hit pause real quick here, and let's get caught up. All right, so after reading section 2.1 here, go ahead and answer a couple questions on Edpuzzle here. Okay, and let's talk a little bit more about net force real quick. Net force. Okay, not this one here. Let's go right here, net force. So I'm going to go ahead and put in Thanos here. Okay, I'm a big Avengers fan here, big Marvel. And click on begin here. All right, so take a look at this game here. So here we have a force of 40 newtons going to the right, and we have 21 going to the left. So what's the actual net force and direction? So 40 minus 21, that gives us 19, right? So 40 minus 19 is 21 newtons, okay? But is it 21 newtons to the left or to the right? So I'm going to say it's, hold on, 40, oh no, hold on, 40 minus 21, 21 means 19 newtons. So there's a net force of 19. Now it looks like it's going to be going to the right here, right? Because there's a leftover. 40 minus 21 is 19, but it looks like it's going to go to the right. Click on that. Hey, we're correct. Now here we have two forces going to the left here. So we just have to add these two together. That gives us 84 plus 71. You have like 2 minutes to complete this, or you have a minute to complete this. Let's try it one more time here. And we'll hit Thanos here. I put Thanos here and begin. All right. Here we have, we got to add these two together going to the left, add these two together here going to the right, and go ahead and tell me what the answer is going to be. All right. I'll go and hit pause. All right. The answer should be 10 newtons to the right. All right. We are correct. Okay. All right. So this is one of the labs you're going to be doing is this net force simulation here. Okay. All right. Let's go ahead and continue on. That's section 2.1. Go ahead here. Go ahead and read about section 2.2 and see what mechanical equilibrium, equilibrium is all about. Okay. All right. Okay. Here's section 2.3. Go ahead and look over 2.3 and talk about support forces and see what that's all about. Okay, we'll hit pause. Okay, all right. Go ahead and let's take a look at section 2.4, equilibrium for moving objects. Go ahead and read section 2.4 and answer some questions that come with that. Okay, and finally, our last section is 2.5 is vectors. Before we read this, I want us to look at a simulation here real quick, and so we have a better understanding of vectors. Okay, so I'm going to go ahead and click on this right here, and here is vectors here. And let's go ahead and let's restart this here. Okay, so here we have this XY Cartesian coordinate system, and we should know from math class that this is, this is section 1, this is 2, 3, and 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so a vector, let's go ahead and I'm going to pull this vector out right here, and let's go ahead and let's put it right here. And I want to make sure it's like right, there we go. All right, so we're in quadrant number 1. Now, what we look at here is that, first of all, this is an arrow here, and it's going to be called vector A. Now, vector A has magnitude. Magnitude means what is the length of this. So over here, when you see this here, these arrows, right, looks like absolute value, that means magnitude. So the magnitude of vector A is 14.1. That means that this is 14.1 units right here. Now, there's a point right here, and this point has x and y coordinates, okay? So this point here, what would the x coordinate be? It would be 10, okay? Which is right here, 10, okay? What would the y coordinate be? It is also 10. So this has an x coordinate or x value of 10 and also has a y value of 10 as well. And notice here the angle. It says the angle here is 45 degrees. That means whenever we do in physics, our angle will always, click on this right, click on, no vector selected, hold on, yikes. Oh, let me go here real quick. Let's do that again. We'll go here, and I'm gonna go ahead and kind of drag this here again. And let's put it like right there. And let me go ahead and go, oh, here we go. I did a little bit better now. Okay, so here, the tip is right here. So the magnitude is 14, okay? The x component is 10 here. Notice the dx, that means the x, well, is 9.9. Let me make it let's make it like right to, let's see. Uh, oh, okay. Well, okay, 9.9. And the y component is also 9.9. Okay. And notice here the angle is 45 degrees. That means with respect to the x-axis here, the angle is 45 degrees. Okay. Let me hit pause real quick. Okay, so let's go ahead and take a look at this vector here again. So it was vector D here, right? So here we have, we'll call it vector D like this here. And we said the magnitude of this vector here is 14. It's 14 here. Now the x component, dx, we have the dx component is what? Looks like 9.9. Okay. And dy, the y component is also 9.9 as well. And we have here that the angle theta is 45 degrees. Okay, so this is vector D. The magnitude is 14. Here the x component, here's the y component, here is theta, which is 45 degrees. Okay, all right. So now okay, let's go ahead and let's try one more here. Let you guys try this one here. So let's go ahead and let's reset here. And I'm going to go ahead and have this vector here. I'm going to put it right here. And I'm going to go ahead and kind of say, here is vector B. Okay. And I want you to tell me what's the magnitude of vector B, what's the angle, what's the x component, and what's the y component. Okay, go ahead and answer that. Now I'll hit pause. All right. Okay, so here is vector B. Vector B is here, and I want you to tell me what is the magnitude, what's the direction or angle, what's the x component, and what's the y component. Okay. All right, let me go hit pause. Okay. All right, we'll go ahead and continue on here. I want you to go ahead and read section 2.5 here, and then we'll end up with Newton's second law. Okay, hit pause. Okay, the last thing we're going to cover here is Newton's second law here. And let me go ahead and take a look at this here. And let's go over here. Okay, so we already know that force was a push or a pull, right? So force uh, we have was a push and or it was a pull. Okay. All right, so now we have here for Newton's second law, sum of the forces is equal to mass times acceleration. Now, mass, we already have some idea of what mass is. Acceleration just tells you how fast you are speeding up or slowing down. So I'm going to say speeding up, speeding, uh, it's going to be speeding up or slowing down. Speeding up or speeding down. Okay, so that's what acceleration is. So there's just three. Now this is the net force. Okay, so here when we do net force, that means that we have a force going to the right minus a force going to the left has to equal mass times acceleration. Okay, all right. So in this answer here, let's go ahead and put in Thanos. There's Thanos. And here they're asking us, we have a force going to the left, we have a force going to the right, force going to the left, and the mass is unknown, but they tell us that the acceleration is at a rate of 2.25 going to the right. Okay, what's the mass of this block? So everything going to the right is positive. So to the right is positive and to the left is going to be negative. All right, so what's force going to the right? Okay, it looks like it's 2.78, right? Newtons here minus 0.5 2.71 newtons is equal to, there's mass, that's m, and the acceleration we have was 2.25. So we got to solve for mass, okay? So if I do this right here, 2.78 minus 0.71, hold on, 2.78 minus 0.71, that should give me 2.07. So 2.07, right, is equal to mass times 2.25. Okay, to solve for mass now, divide both sides by 2.25. Divide this here by 2.25 like so, and we get that mass should equal, divided by 2.25, should be 0.92. So 0.92 kilograms should be our mass, right? So go over here, we'll enter in 0.92, hit submit, and it says, great, Thanos, your answers were within the acceptable range. All right, now before we leave here, let's do this last one here. We'll hit refresh here, and we'll hit begin, and I'll go ahead and put Thanos here. Okay, now, let's go Thanos. All right, now here we want to find the acceleration. Okay, so we have force going to the right, force going to the left. We have the mass. You need to solve for A. So we have this, we have this, we have the mass. You solve for acceleration. Okay, I'm going to hit pause. All right, so the final answer should have been 4.04 meters per second squared. All right, that will conclude video number 3, and I look forward to seeing you guys in the fall semester. Okay, take care. Enjoy your summer.